So once again, I welcome you all to this NEET 2023 Physics course. Okay, and today officially we are going to start with our theory lectures. Okay, so yesterday we had an introduction. It was nice to talk with you people. All right, so today we'll start with the basic mathematical methods for physics. Okay, so all of you have maths, Ashwin?
Yes, sir.
Okay, everybody had maths. All right. So still, I will like if you pay your full attention, okay, because these methods are needed, very much needed in physics. Okay. So let's go ahead. So let's start with trigonometry. Okay. So we know what is trigonometry. Anybody can define trigonometry? It's the branch of mathematics which deals with what?
Angles.
Okay. It deals with study of angles and sides of a triangle, right? Their relations with sides of triangle and circles, of course. Okay. So how to measure an angle? Okay, we know what is an angle, right? So if we draw, let's say, these two lines, okay, two rays, as we say. So this one is, let's say, the initial ray. This one is terminal ray. So if we rotate this ray from here to here, okay, so that rotation creates this quantity known as angle. Okay, so this angle, let's denote it by theta. How do we measure that rotation? Okay, so measure of that rotation is this angle. How do we measure the rotation? So there are actually these two ways of measuring of an angle. So first one is this system called as sexagesimal system, and second one is known as the circular system. Okay, so what is sexagesimal system? So in this system, what we do is we find out, let's say, we describe an angle considering a circle. Okay, so in circular system also, we consider a circle only. So what we do here? So here, let me add a page. All right, so let's say we have this circle over here, and let's say we start from here. Okay, inside the circle, we start from this point. Let's call it A. So now this radius is rotated. You can see this, no? Yeah, this is not going out.
Yes, sir.
It's not going out of the screen, no? No, no. Okay, so inside this circle, what we do is we rotate this radius, okay, from the initial position to the initial position. Okay, so final position will be equal to what? Initial position. So this much rotation over a complete circle, it is called as 360 degrees. Okay, we call it 360 degrees. All right, so rotation over this complete circle is 360 degrees. So this is how we define degrees. Then we further divide the degree into seconds, okay, into minutes. Okay, so 1 degree is 60 minutes. So this is the symbol, this one is the symbol, dash is the symbol for minutes, and 1 minute is further divided, okay, 1 minute is further divided into seconds. So this is the symbol for seconds. Okay, so either I can write like this, or I can write like this. This is 60 minutes, and this is what? 60 seconds. So 1 minute is further divided into 60 parts, and each part is known as 1 second. Okay, so is there any confusion till now? Is there any question?
No, sir.
Okay, so this part is clear to everybody.
Yes,
Yes,
sir.
sir.
Okay, you already, how many of you already knew this? I guess everybody knew this, right?
Yes, sir.
Okay, so then there is second system. So second system is known as the circular system. So in the sexagesimal system, okay, what we do is the rotation over a circle is called as 360 degrees. In circular system, what we do, we measure angle in terms of length of the radius. Okay, so let's say we take a circle again, and let's take arc of this circle. Okay, so if I take an arc from this point to this point, let's say, so it will subtend some angle at the center of the circle. Okay, it subtends an angle at the center of the circle. So how do we define this angle in the circular system? It is length of this arc, okay, this length divided by the radius. All right, so it is in multiples of radius. Okay, so let's say this length of the arc is s, okay, radius is r, so theta is equal to what? S divided by r. This is how we define. Okay, so let's say length of this r is equal to, it's equal to 1 radius. Then how much will be the angle? It will be r upon r, okay, that is 1, and unit of this angle in this system, the circular system, is called as radian. Okay, the unit here is known as radian. All right, so this is clear, this thing is clear.
Yes, sir.
Okay, so I have already written down actually the definition of radian. What is 1 radian? It is an angle subtended by at the center of the circle by an arc whose length is equal to what? 1 radius. Okay, whose length is equal to radius of the circle. So angle, we define it as length of the arc divided by radius. Okay, so if I draw a circle over here, okay, so let's say we have this angle theta. So this is equal to what? Length of this arc from this point to this point, A to B, divided by radius r. Okay, so theta equals to S over r. Okay, okay, let's say we start from this point, okay, and we come back to this point. So how much will be the length of the arc? If we start from some point on circumference of circle and come back to the same point, how much would be the length of the arc?
Circumference 2 pi r.
Yeah, it's circumference of circle, right? So I can say angle over the complete circle. Okay, or
360 degree.
yeah, in degrees it is 360 degrees. We have already defined it. Okay, so angle over complete circle, or I would say complete rotation on a circle. Okay, let's call it theta max, I will call it. That's the maximum possible angle, okay, that we can define. Actually, we can define an angle which is in multiples of this one also. Okay, so but for one rotation, the angle that we get, I will call it the maximum possible angle. Okay, so it is theta max. It is length of this r, s divided by r, and how much would be the length of arc? As we discussed, it will be equal to the circumference of circle. Okay, so it is circumference of circle divided by radius. So it is 2 pi r divided by r. So this r and r gets cancelled out, and the angle that you get is equal to what? 2 times pi. Okay, so it is 2 pi radians. Okay, so what is my theta max? It's angle over one complete rotation, and it's equal to what? 2 pi. So angle over a complete circle or one complete rotation on a circle is equal to 360 degrees. So I can say 2 pi radians is equal to 360 degrees, right? And therefore, what do we get? If I want to, from here, I can convert radians to degrees and degrees to radians. both ways I can do. So if I want to convert radians to degrees, I will take that 2 pi on the other side. Okay, 1 radian equals to how many degrees, right? And if I want to convert degrees to radians, I will take 360 degrees, 360 on other side. Okay, so let's do both. So 1 radian equals to 360 degrees divided by 2 pi. Okay, or I can say if I divide by 2, it will be 180 divided by pi in degrees. Okay, and if I want 1 degree, then I will take this 360 on the other side, so it will go into the denominator. So it is 2 pi divided by 360 radians, or I can write it as pi by 180 radians. Okay, so now we have found it, but we have to memorize it. Okay, so this is clear.
Yes, sir.
Okay, good. So this is how we find an angle. Okay, after that, I added 2 pages, I guess. Then there are some trigonometric ratios. So sine, cosine, tangent, secant, cosecant, cotangent. These are the 6 trigonometric ratios. And how do we define them? So let's say we take a triangle. What kind of a triangle? A right angled triangle. Okay, and then let's say we call this angle theta. Okay, so for this theta, this is the opposite side, this one is opposite side, and this is an adjacent side. Okay, and this is hypotenuse. All right, so this is hypotenuse, this is adjacent side, and this one is opposite. It's not going out of the screen, no, opposite side. Okay, and see, the ratio of this opposite side to the hypotenuse, it is known as sine. Okay, ratio of adjacent side to the hypotenuse, it is known as cos. Okay, short form of cosine is cos. After that, ratio of sine to cos. Okay, what will be that? It is, see, its opposite side upon hypotenuse is sine, then adjacent side divided by hypotenuse is cos. So if I divide sine by cos, what do I get? I get tan. On right hand side, the hypotenuse gets cancelled, and I get what? Opposite side divided by adjacent side. Okay, do we need to do that? It's clear, no?
Yes, sir.
Okay, after that there is sec. So what is sec? So sec is 1 upon cos. Okay, so what is cos? Cos is adjacent side divided by hypotenuse. So sec would be what? Hypotenuse divided by adjacent side. So sec is what? It is 1 over cos. Okay, then next is cosec. So cosec I can write as CSC, or I can also write it as cosec. Okay, so whichever way you prefer it. So it is 1 over sine. So sine is opposite side divided by hypotenuse. So cosec will be what? 1 over sine, that is hypotenuse upon the opposite side. And the last one is cot or cotangent. It is 1 over tan. So it is adjacent side divided by opposite side. Okay, so these are the 6 trigonometric ratios, and we have to memorize values of these ratios for some angles, for particular angles. Which are those angles? These angles 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay, so these angles will appear many times when we study physics or maths also. So it's better to memorize the trigonometric ratios for these angles. Okay, So these are the trigonometric ratios. So sine, let's say angle A is equal to 0 degrees. So sine of that angle is what? It's 0. Sine 0 is 0. Okay. Then cosine of A is equal to 1. Okay. Cos 0 is 1. Then sine of 30 degrees is 1 by 2. Okay. Sine of 45 degrees is 1 upon root 2. Alright. Then sine of 60 degrees is root 3 by 2. And sine of 90 degrees is 1. Okay. So if you reverse this, so you are going from 0 to 90. The values of sine of 0 to 90 are values of cos from 90 to 0. Okay. So in opposite order. Alright. See. So sine 0 is 0. Cos of 90 is 0. Then sine of 30 is 1 by 2. Cos of 60 is 1 by 2. Okay. Sine of 45 is 1 over root 2 and cos of 45 is also 1 over root 2. The sine of 60 is root 3 by 2. Then cos of 30. See, here we are going in this order and here we are going in the opposite order. Okay. So now there is actually a better way to memorize this, or if you don't, I mean, you have to memorize these values of sine and cos, but let's say you forget. So there is a way, a trick to calculate. Okay, so let's see how. All right, so these are values of sine and cos and tan. So you will memorize sine, cos, tan, then others you can find out, right? If you know sine, cos, tan, you can take the reciprocal of that and you can find out what? Cos, sec and cosec. Okay, so let's see a trick. So what's the trick? So just write down 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Okay, then I will write sine and cos. Here I will write 0, 1, 2, 3, 4. Then here in the row of cos, I will write the same numbers in the opposite order. So 4, 3, 2, 1, 0. Okay. After that, what I will do is I will divide all of these numbers by 4 and I will take the square root. Okay. So what I will do is I will take square root like this. Okay. And so if I take a square root, sine of 0 will be what? It will be 0 upon 4 and square root of that. If I take square root of 4, what will be that? It's 2. Okay. So we divide all of these by 2. So you got the trick. So now once again I will write sine. See, sine of 0 is how much? Square root of 0 upon 2, it's 0. Okay, sine 30, square root of 1 upon 2, so it's 1 by 2. Then sine of 45 is root 2 divided by 2. So if you divide the numerator and denominator by root 2, okay, so what will you get? I mean, if you cancel out, if you write this 2 in the denominator as root 2 times root 2 and you cancel out this root 2 with 1 root 2 in the denominator, you will get 1 upon root 2, right? So here next you get root 3 by 2. Next you get root 4 upon 2. So root 4 is 2. 2 divided by 2 you get 1. Okay. And similarly you can write cos. So in cos, so this one is root 4 divided by 2. Root 4 is 2. Okay, so 2 upon 2 is 1. Here it's root 3 by 2. So we can directly write down root 3 by 2. The next is 1 over root 2. Next is 1 by 2 because square root of 1 is 1 only. And next is square root of 0 upon 2. So square root of 0 is 0. Okay, so cos of 90 is 0. All right. So is this thing clear? Is the trick clear?
Yes, sir.
Okay. So how many of you knew this already, or everybody knew this?
Only I know, sir.
Okay. Florence, did you know?
Yes, sir.
Yeah. Okay. So my maths teacher taught me this when I was in 11th standard, I guess. He was very good teacher. Okay. So this is very beautiful trick. All right. So we have to memorize sine, cosine, and tan of angles from 0 to 90. Okay. Which angles? 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees. Okay. We have to memorize sine and cosine and tan. Actually, you need to memorize only sine and cosine. You can find out tan also, right? Just take the ratio of sine and cosine, and everything else you can find out. Okay, but this much we should know. We should by heart it, and even if we forget, we can quickly find it out using this trick. All right. Next, this is a big thing. Okay, and slightly intimidating. We have to memorize some trigonometric relations. All right. So these are the relations. So sine of sum of two angles. Okay, sine of sum of two angles. So first angle is A, second angle is B. So it is sine A cos B plus cos A sine A. All right. Next, sine of difference of two angles. Sine of A minus B is sine A cos B minus cos A sine B. Next, cos of sum of two angles is cos A cos B minus sine A sine B. And cos of difference of two angles is cos A cos B plus sine A sine B. Okay. So we have to memorize this formulae. Then these are double angle formulae. Okay, sine of 2a is 2 sine a cos. Cos of 2a is cos square a minus sine square a. 1 minus 2 sine square a, and there is 2 cos square a minus 1. Okay, then these are triple angle formulae. Okay, let's say you take an angle a. Okay, you take 3 times of that angle and you find sine and cosine of that angle. So these are the formulae for that. So this will come rarely, but we should know from here to here at least. And at least we should know these four formulae. But okay, so this one also we should by heart. It comes very often. Sine of 2a, sine of 2 theta is 2 sine theta cos theta. All right. But let's say you forget these. So you can find out how. So what is 2a? It is a plus a, right? So you know the formula for sine of a plus b. It is sine a cos b plus cos a sine b. Okay. So what will be sine of 2a? Sine 2a equals to sine of a plus a. Okay, that is sine of first a multiplied by cos of second a plus cos of first a multiplied by sine of second a. Okay, is this pencil clear? Let me increase the font. All right, can you see this, or it is blur?
Yes,
Okay, so this is equal to, you can write sine a cos a plus cos a sine a. So this is also what? Sine a cos a. So it is 2 times of sine a cos a. Okay, so what have we used? We have used this formula. This formula, sine a cos b plus cos a sine b. So in place of b, we have put a. All right. So similarly, if I want to find out cos of 2a, I will use this formula. Okay, it is cos of a plus b. So in place of b, I will write a only. It is cos of 2a, a plus a, right? So we can find out that formula. Okay, so cos 2a equals to cos of a plus a. And what's the relation? It is cos a cos b minus sin a sin b. Okay, so cos of a multiplied by, in place of b we have put a, so cos a into cos a minus sin a sin a. Okay, so we have cos square a plus sin square a, sorry, minus cos square a minus sin square a. Okay, so we got this first identity. All right, then we can substitute. So do you know sin square theta plus cos square theta equals to how much?
1.
Okay, so everybody knows this. So we can place, so we can write here this cos square a as 1 minus sin square a. Okay, and again we have this minus sin square a. So what do we get? 1 minus sin square a minus sin square a, that is 1 minus 2 sin square a. Okay, and so in this case we have put cos square a equals to 1 minus sin square a. Now similarly we can put 1 minus cos square a in place of this sin square a. Okay, so what do we get? Cos square a. Okay, so we already got this formula. Cos square a minus, in place of sin square a I will put 1 minus cos square a. All right, so that is equal to this cos square a, and minus minus becomes plus. Okay, so cos square a minus 1 minus minus plus cos square a, so that is 2 times cos square a, 2 times cos square a minus 1. Okay, so we got this formula also. Okay, similarly we can find out sin 3a, cos 3a. Okay, this will be needed very very rarely, but these formulae sin of 2a and cos of 2a, they will be needed. All right, so there are lots of things to by heart now, right? The
Yes, sir.
trigonometric ratios, these formulae. Okay, so formulae for sine and cosine of sum and difference of angles, these are must. These we can find out, but this formula, it comes very often, so we should memorize this one also. Okay, after that we have sine of some angle plus sine of some other angle. Okay, so sine c plus sine d, the formula for that is 2 times of sine of c plus d by 2 multiplied by cosine of c minus d by 2. Okay, sine c minus sine d is 2 times of cos of, see here order of sine and cos has changed, and in bracket we have c plus d by 2, and in second bracket we have c minus d by 2 only. Okay, then cos c plus cos d is 2 times of cos of c plus d by 2 into cos of c minus d by 2, and cos c minus cos d is 2 times of sine of c plus d by 2, and 2 times of multiplied by sine of c minus d by 2. Okay, so these formulae also we need to memorize, and 2 formulae for tan, that's it. Okay, so tan of a plus b is tan a plus tan b divided by 1 minus tan a tan b, and tan of a minus b, so in this formula just put minus in place of plus, you will get the second formula. Okay, so it is tan a minus tan b divided by 1 plus tan a tan b. Okay, so this many formulae you have to memorize. So any question till now? No, sure.
No, sir. Yes,
No,
sir.
sir.
Okay, so where do we use this formula? First thing is, let's say for an example, I want to find out sine of 15 degrees. How would I find? So 15 degrees, I can write it as 45 degrees minus 30 degrees, right? Okay, or I can write it as 30 degrees minus 0 degrees. I guess that would be better because sine 0 is 0. Okay, so sine of 30 degrees, no, sine of 45 minus 30. What was I saying? 30 minus 0. Okay, that will be 30. Okay, then this will be what? Sine A cos B. So or A is 45, or A is 45, or B is 30. So we have sine A cos B minus cos A sine B. So sine of 45 multiplied by cos of 30 degrees minus cos of 45 multiplied by sine of 30 degrees. Okay, so what is sine of 45? Sine and cos, this is one angle for which sine and cos values are equal. They are 1 upon root 2. Okay, so 1 upon root 2 multiplied by cos of 30. So how much is cos of 30? Root 3 by 2. Okay, minus 1 over root 2 multiplied by sine of 30. So sine of 30 is 1 by 2. Okay, so denominator is equal. See here, denominator is equal, right? It is root 2 multiplied by 2 and root 2 multiplied by 2. So we can write in denominator 2 root 2 and numerator will be what? Square root of 3 minus 1. Okay, and we should remember two square roots also, at least two. Okay, what are they? Square root of 2 is 1.41. I guess there is one more 4 over here, 1.414, and square root of 3 is 1.732. Okay, so then now if you want to find, so in NEET, I don't think there will be lots of calculations, but we can have some questions where we need to solve up to this, let's say. Okay, there will be some questions, there can be some questions where we need to use formulae like this. Okay, the formulae for sine of sum of two angles or difference of two angles. Okay, so this is the one case where we need to use these formulae. All right, then second case is when we study wave optics. Okay, actually wave motion and wave optics. Angle from 0 to 360 degrees. It is divided in 4 quadrants. Okay, so first quadrant is from 0 degrees to 90 degrees. Okay, second quadrant is from 90 degrees to 180 degrees. Third quadrant is from 180 degrees to 270 degrees, and the fourth quadrant is from 270 degrees to 360 degrees. So 360 degrees will coincide with 0 degrees. Okay, so this is 360 degrees. Okay, so this is third quadrant and this is the fourth quadrant. Okay, so now inside the first quadrant, all the 6 trigonometric ratios are positive. They are greater than 0.
All symmetrical, sir.
Yeah, all trigonometric ratios, the values of sine, cos, tan, okay, sec, cosec and cot, all of them are positive. Okay, so here I will write all positive, or I can say A positive. Okay, blood group. Let's write all positive. Okay, the second one, sine is positive, Okay, so if sine is positive, its reciprocal is going to be positive, right?
Yes, sir.
Yes, sir.
Okay, so sine is positive, that means cosec is also positive. Okay, so we'll just memorize that sine is positive, so cosec is automatically positive. Okay, so sine is positive in this quadrant, all other ratios are negative, that means cos is negative. Okay, and everything else which is related with cos would be negative. So cos is negative, reciprocal of cos, that is sec. Sec would be negative. Then sine upon cos. So sine is positive, cos is negative. That's why the ratio will be negative. Okay, tan will be negative. Cot will be negative. All right. Then in third quadrant. So
So there is a trick, sir.
okay, what's the trick?
All silver teacups, sir. All for the first quadrant, yes. Then T, then C, sir.
Okay, all silver.
Teacups.
Teacup.
All right. So I didn't know about this trick. So tan, here tan is positive and here cos is positive. Okay, so your trick is all then silver teacup. Oh, okay, great. Okay, so all positive in first quadrant. In second quadrant, sine is positive and its reciprocal, which is cosec. It is also positive. All other are negative. In third one, tan is positive, so its reciprocal is going to be positive. Okay, all other are negative. And in last quadrant, cos is positive. So which one will be positive? If cos is positive,
Secant.
Secant,
secant,
sir.
yeah, secant will be positive. Okay, so secant is positive, others are negative. All right, so this is the quadrant rule, okay, of trigonometry. And there is one more thing. So, okay, let me add a page. So I want to find out sine of minus theta. So I can write this as sine of 0 minus theta. Okay, and it will be minus sine theta. How? Let's see. It is sine of 0 cos of theta minus cos of 0 sine of theta. Okay, sine of minus theta we are finding. So sine 0 is 0, that means this first term becomes 0. Okay, and that's why we are left with second term only. And how much is cos 0? So cos 0 is 1, so it is minus of 1 multiplied by sine theta, that is minus sine theta. So this is sine of minus theta. Okay, so what is minus theta? So let's say we take an angle like this. So anti-clockwise angles are positive. Okay, so let's say we start with x-axis or from anywhere. If we go in anti-clockwise direction, then angles are said to be positive. If we go in clockwise direction, then they are said to be negative. So this is theta. What will be minus theta? This one will be minus theta. Okay, right?
Sir.
Yes, sir.
Or okay, after that, next is cos of minus theta. What will be cos of minus theta? So again, we'll
Cos
use,
theta.
Cos theta.
no, it's cos theta. Okay, so what's the formula? So it is, I can write it as, in terms of difference of two angles, I can write it as cos of 0 minus theta. Okay, so our A here is 0, B is theta. So it is cos A cos B. So cos 0 cos theta minus sine 0. So here it's plus actually, plus, okay, sine 0 sine theta. Okay, so cos 0 is 1, sine 0 is 0. So the second term will be 0, right? And first term is cos 0. Cos 0 is 1. 1 multiplied by cos theta. So we have cos of theta. Okay, so sine of minus theta is minus sine theta. Cos of minus theta is cos of theta. Right? Then let's add one more page, or I will write on this page itself. So what is sine of 2 pi plus theta? So intuitively it must be clear. See, if I take a circle and I take an angle, so I take an angle from this point to this point. Let's call it AB. Okay, so angle subtended by arc AB at the center. It's theta. So how much is 2 pi? 2 pi is 360 degrees. So from here to here. Okay, so if I add 2 pi to this theta, so let's say I go from A to B. Okay, I have rotated the radius with angle theta. Then I go from that position to the same position. So how much of angle have I added? 2 pi, right? Okay, so what I'm saying is this much rotation plus one complete rotation from this point. So how much will be this total angle? Will be 2 pi plus theta. Okay, so now can you distinguish between these two? So final position is same. Okay, so sine or cos or whatever of theta plus 2 pi plus theta must be equal, right?
Yes, sir.
Okay, and we can check it using this formula. So sine of 2 pi plus theta will be sine of 2 pi multiplied by cos of theta plus cos of 2 pi multiplied by sine of theta. Okay, so sine of 2 pi is 0. Okay, how much is cos of 2 pi? Okay, sine and cos values of 2 pi and 0, they are equal. Sine of 2 pi is, how much is sine 0?
0.
Sine of 2 pi will be 0. Okay, so see in 2 pi also we complete one rotation, that means we come back to the same position. Okay, so sine of 2 pi is also equal to 0. Right, so sine 2 pi is 0. So it is 0 multiplied by this cos of theta. So this one will become 0 and cos 2 pi is equal to 1. Okay, so we have 1 multiplied by sine theta, that is sine theta. Similarly, I can write sine of 2 times 2 pi. Okay, so that means I am covering what? 2 rotations. Okay, so starting from, let's say I go from 0 degrees to theta degrees, or 0 radians to theta radians, and from there I cover 2 rotations. So that will be 4 pi angle. Okay, so it is 4 pi plus theta, and that's equal to how much? It will be just sine of theta. Okay, because sine of 4 pi is also equal to 0. Okay, so is this thing clear?
Yes, sir.
Okay, so I'm sorry, I can write a general rule. So general rule will be what? Sine of n times of 2 pi, okay, or twice n pi plus theta is equal to sine of theta. Okay, similarly I can say cos of n times of 2 pi plus theta is equal to cos of theta. Is this clear?
Yes,
Yes,
sir.
sir.
Okay, so now in trigonometry, what is important? So we should be able to apply trigonometric formulae. Okay, and we should be able to apply them fast. Right? Okay, so
Yes, sir.
is there any question till now?
No, sir.
No, sir.
No, sir.
Okay, so this is all I wanted to cover in this lecture. I mean, I just wanted to cover trigonometry only. Okay, we can do some examples, but they will be repetitive. So, okay, let's stop here. And tomorrow, not tomorrow, day after tomorrow, we'll start with calculus.